Welcome to our deep dive into the future where sci-fi tech is becoming reality. Today, we're exploring 6 powerful technologies that could save humanity or, in the wrong hands, destroy us. For every world-saving breakthrough, there's a risk just as significant. We'll cover everything from space-based weapons to mind-machine connections and how these innovations are reshaping our destiny. This isn't about fear-mongering, it's about being informed. Let's look at the good, the bad, and the genuinely terrifying aspects of what's coming. Let's get into it. Before we jump in, let's set the stage. The tech we're discussing isn't just an upgrade, it's a fundamental shift, like the printing press or the internet. These 6 technologies could transform our biology, environment, intelligence, and even our place in the cosmos. Each one is a double-edged sword, immense promise but also unprecedented risk. Think nuclear energy, clean power but also atomic bombs. The stakes are higher than ever, and the line between breakthrough and catastrophe is razor thin. As we go through each, consider both the utopian and dystopian possibilities. These aren't just gadgets, they're game changers, backed by billions in research. The question isn't if they'll arrive, but how we'll manage them. Ready? Let's start with something straight out of a spy thriller. We're heading to orbit. Let's talk about lasers. First up, orbital lasers. These aren't your average laser pointers. We're talking about incredibly powerful beams of energy, generated from space. Imagine the possibilities, both the incredible potential and the inherent risks, when we place such power in orbit around our planet. Giant lasers on satellites orbiting Earth. A network of these could revolutionize several aspects of our lives, from planetary defense to energy distribution. But with great power comes great responsibility, and the potential for misuse is a serious concern that needs careful consideration. The upside? Planetary defense. It's a concept straight out of science fiction, but it's becoming increasingly plausible. An orbital laser could nudge an incoming asteroid off course, acting as a sort of cosmic billiards cue. By gently pushing the asteroid over time, we can alter its trajectory, potentially saving us from extinction. It's a safeguard against a catastrophic event, a way to ensure the survival of our species. The dinosaurs didn't have orbital lasers, but we might. Another benefit: energy transmission. Imagine a world powered by clean, limitless energy beamed down from space. Solar farms in orbit could beam clean, limitless energy to Earth using lasers. These space-based solar power stations would be unaffected by weather or nighttime, providing a constant source of energy. This could revolutionize our energy infrastructure and help combat climate change. But here's the dark side: the potential for weaponization. Those same lasers could be weaponized, turning these satellites into instruments of destruction, targeting cities or infrastructure at the speed of light. There would be virtually no warning and no defense. The implications are terrifying. Whoever controls them holds the ultimate high ground, possessing the ability to project power anywhere on the planet, potentially holding the world hostage. It's a scenario that could lead to global instability and conflict. Accidents or malfunctions could be catastrophic, leading to unintended consequences, with a stray beam causing massive destruction. Imagine a laser misfiring and igniting a wildfire, or worse, striking a populated area. The precision and reliability required are almost unimaginable. We're talking about technology that needs to function flawlessly in the harsh environment of space, with no room for error. So, orbital lasers, a planetary shield and energy source, offering incredible benefits to humanity. Or the perfect doomsday weapon, capable of unleashing unimaginable destruction. The difference? Just a few lines of code. A simple change in programming could shift the purpose of these lasers from defense to offense. That's the dilemma. We stand at a crossroads, with the potential to use this technology for good or for evil. The line between salvation and destruction is razor thin. It requires careful consideration, international cooperation, and a commitment to responsible development. It's a tool for both hope and terror, a reflection of our own capacity for both creation and destruction. The future of orbital lasers depends entirely on how we choose to use them. It's a decision that will shape the future of humanity. Next up, intelligence beyond our own. We're diving into the world of artificial intelligence. Let's talk AI. What is it and what does the future hold? Artificial intelligence is rapidly evolving and already deeply integrated into our daily lives. From suggesting what to watch next to powering complex algorithms behind the scenes, AI is reshaping our world in profound ways. But the next leap, artificial general intelligence, or AGI, represents a monumental shift. AGI aims to create AI with human-level cognitive abilities, capable of understanding, learning, and applying knowledge across a wide range of tasks, much like a human being. This advancement could change everything, ushering in an era of unprecedented possibilities and unforeseen challenges. AGI could revolutionize healthcare, transforming how we diagnose, treat, and prevent diseases. Imagine AI-powered systems that can analyze medical data with unparalleled speed and accuracy, leading to earlier and more precise diagnoses. It could be designing personalized cures tailored to an individual's unique genetic makeup, paving the way for truly personalized medicine. AGI has the potential of eradicating diseases that have plagued humanity for centuries, offering hope for a healthier future for all. It could solve scientific mysteries that have baffled researchers for decades, accelerating the pace of discovery and innovation across all fields. AGI could tackle climate change by developing innovative solutions for carbon capture, renewable energy, and sustainable agriculture, helping us mitigate the effects of global warming and optimize global systems, from supply chains to energy grids, making them more efficient, resilient, and sustainable. Imagine a million Einsteins or even more working non-stop 24/7 on humanity's biggest challenges, from curing cancer to achieving world peace. But the risks, they are massive and demand careful consideration. The control problem, a critical challenge we must address. How do we ensure a superintelligent AI aligns with human values, ethics, and goals? This is a question that requires global collaboration and careful planning. Misaligned goals could lead to disaster, unintended consequences that could have catastrophic effects. Think the infamous paperclip maximizer, a thought experiment illustrating how a seemingly harmless goal, if pursued relentlessly by a superintelligent AI, could lead to the destruction of everything else. Weaponized AI could automate warfare, escalating conflicts and making them more unpredictable and dangerous. These systems could be making life-and-death decisions in milliseconds, far faster than any human could react, raising serious ethical and strategic concerns. AI could also disrupt economies, creating new forms of inequality and instability. It could be automating not just manual but cognitive jobs, displacing workers across a wide range of industries. This could lead to mass unemployment and inequality, exacerbating social tensions and creating new challenges for policymakers. And if AI surpasses us intellectually, becoming superintelligent, what happens to our place in the world? What role will humans play in a future dominated by superintelligent machines? The emergence of AGI could be humanity's greatest achievement, a testament to our ingenuity and our relentless pursuit of knowledge. But it could also be our last, if we fail to address the risks and ensure that AI is aligned with human values. The stakes couldn't be higher as we stand at this critical juncture in human history. Next, let's shrink things down to the atomic level and explore the world of the incredibly small. Nanotechnology is up next, promising revolutionary advancements in medicine, materials science, and manufacturing. The power to build or destroy matter at will, all at the smallest scale imaginable, opens up a world of possibilities and potential dangers. Let's dive in and explore the fascinating realm of nanotechnology. Nanotechnology. It's a term that conjures images of futuristic labs and microscopic machines. But what does it really mean? At its core, nanotechnology is about building and manipulating matter. We're talking about working at the scale of atoms and molecules, the very building blocks of everything around us, atom by atom. It's a painstaking process, but the potential rewards are enormous. Imagine creating materials with properties we've never seen before, or building devices so small they can navigate the human body. In medicine, the possibilities are particularly exciting. Nanobots could be programmed to hunt cancer cells, acting as targeted missiles against the disease. They could also repair damaged tissue, accelerating healing and potentially reversing the effects of aging. And deliver drugs with pinpoint accuracy, ensuring that medication reaches only the affected cells, minimizing side effects and maximizing effectiveness. This level of precision could revolutionize how we treat a wide range of illnesses. But the benefits of nanotechnology extend far beyond medicine. Environmentally, they could clean up pollution, breaking down harmful substances into harmless components, capture carbon, pulling CO2 directly from the atmosphere to combat climate change, and create ultra-efficient materials, lighter, stronger, and more durable than anything we have today. These materials could transform industries from aerospace to construction, leading to more sustainable and efficient products. The promise: a world without disease or waste, a world where resources are abundant and technology solves our greatest challenges. Built from the atoms up. But with such immense power comes immense responsibility. But the risks are chilling. The gray goo scenario self-replicating nanobots spiral out of control, consuming all organic matter to replicate themselves, consuming everything in their path. A nightmarish vision of runaway technology. Weaponized nanobots could target individuals, delivering toxins or disrupting vital bodily functions. Or populations invisibly, creating a silent and undetectable threat. Unknown health and environmental effects could emerge as we grapple with the long-term consequences of widespread nanoparticle exposure. As trillions of nanoparticles enter our bodies and ecosystems, we simply don't know what the ultimate impact will be. Nanotech offers radical creation, but also the risk of total, uncontrollable destruction. It's a double-edged sword with the potential to reshape our world for better or for worse. The power to build and the power to consume, to heal and to harm, to create and to destroy, are two sides of the same coin. As we move forward, careful consideration and ethical guidelines are crucial to ensure that nanotechnology benefits humanity as a whole. Next, let's talk about changing the entire planet. Geoengineering is humanity's emergency brake for climate change. Can we control the climate, or will it control us? Let's find out. Geoengineering is up next, the stakes planetary. Geoengineering means deliberately altering Earth's systems to fight climate change. Carbon dioxide removal pulls CO2 from the air. Giant machines, ocean fertilization, or massive reforestation. Solar radiation management reflects sunlight away, cooling the planet, like spraying aerosols into the stratosphere. The upside, we could halt or reverse global warming, buying time to fix emissions. But the risks are global. Messing with the climate could trigger droughts, floods, or famine in unpredictable places. If we start, we can't stop. Ending geoengineering suddenly could cause catastrophic temperature spikes. Who controls the thermostat? One country's solution could be another's disaster. Geoengineering could even be weaponized, used to harm rivals. And the very idea of a fix might make us less likely to cut emissions. It's a gamble with the only planet we have. Next, let's go inside the human mind. Brain-computer interfaces are blurring the line between human and machine. Liberation or ultimate control? Let's explore. Brain-computer interfaces connect our minds directly to machines. For people with paralysis, BCIs can restore movement and independence. They could treat blindness, depression, or epilepsy, healing the mind and body. But BCIs also promise enhancement, instant knowledge downloads, telepathic communication, and merging with AI. The risks? Profound. A hacked BCI could steal thoughts, memories, or even control actions. Privacy vanishes. Who owns your neural data? If only the wealthy can afford enhancements, we risk a new kind of inequality cognitive. And if we edit memories or personalities, where does you end and the machine begin? BCIs could cure or control, liberate or enslave. The line is thin, and the consequences enormous. Now let's bring it all together. The future is in our hands. The choice is ours. 6 technologies each with the power to save or destroy. Orbital lasers, AI, nanotech, geoengineering, and brain-computer interfaces. Their impact depends on how we develop, regulate, and use them. Technology is neutral. The outcome is up to us. We must be active participants, shaping the future with foresight and ethics. This conversation needs everyone's voice. Which technology excites or worries you most? Let us know in the comments. The more we talk, the better prepared we'll be. Thanks for watching. Don't forget to like and subscribe for more future-focused content. See you in the next one.